Hi, welcome back to another tutorial. And this time we're going to talk about OSPF or Open Shortest Path First Protocol. This is a protocol that is being used to distribute routing information and is designed by IETF to handle more routers for corporations and is used to replace RIP since the OSPF has more advantage. Now let's take a look at an example here. So you have here site 1 C and then site 1, site 2. You have here OSPF process 2, OSPF process 2. And when data goes to the cloud, there are a lot of routers that are connected together. With OSPF, if it is configured, it's going to look for the shortest path. Say, for example, from site 1 to site 2, CE2. Okay, so when data go or the packet goes through here, it's going to evaluate which one has the shortest path going to the CE2 router. Okay, so if it finds out the shortest path, that's the time that it sends the data and then sends it to the CE2 router. Okay, so that's just a quick overview of how OSPF works. We're going now to try OSPF in Packet Tracer. Okay, so we're good to go. We're now going to use three generic routers for our setup, and then these three generic routers, okay, not like the other routers that we have used on our previous tutorial, these generic routers already have two terminals for serial ports. Okay, so we do not have to add a component for the terminal like what we did before on our previous tutorial, and that is adding the WIC 2T or two terminals of serial ports. For this one, we do not have to add. We can just connect the router to router without even adding components for two terminal serial ports. Okay, so we're going to three routers and then two generic computers also. And this is how we're going to set up so that we're going to test later the OSPF protocol. Okay, we're going to connect now. So this is what we're doing is auto connection only. So if we do that manually, that is crossover for computer to router, and then router to router is DCE terminal, DCE connection serial. Okay, so IP configuration for PC0 is 1.1. I'm sorry, that's 1.2. And then for the default gateway is 1.1. Okay, so by the way, we need to write down the network that connects our PC0 to router 0 and then router 0 to router 1. That's another network. This is 10.0.0.0, and then for router 1 to router 2, 11.0.0.0. And another, we need to connect router 0 to router 2. We forgot to connect that earlier. So that will be 12.0.0.0. And then another network for router 2 to PC1, 192.168.2.0. Okay, so they're now connected. So we're now going to configure the IP address of our PC2. Okay, so that will be 2.2, and then the default gateway is 2.1. And now we can check connections by just hovering the pointer on the connections. So that means, okay, say for example, this one, hovering it to that connection. That means serial 2 to serial 2, serial 2 to the serial 2, and then serial 3 to serial 3. Okay, so serial 3 to serial 2. Yes, if you can see, as you can see, there's okay. So we now know the connections. So we now go to route. Okay, so fast Ethernet 00. So we're now going to put an IP address. So 192.168.1.1. Then turn it on. And then serial 2. Remember that is serial 2 serial. Okay, connecting 0 and router 1. So the IP address of this is 10 10.10.02 on and then 2550. Okay, so let's set it to 64,000 and then connection between router 0 to router 2 and that is serial 3. So turn that on. So we're going to set it to 64,000, the clock rate, and then the IP address is going to be 12.12.0.3. Okay, so it's just a static assignment. So, okay, so for simplicity, this is just an example of OSPF just to demonstrate. Okay, so for router 1, we're now going to configure. So, so it doesn't have fast Ethernet, so we do not have to set that up. For serial 2, so we're now going to, so so the IP address now this is going to be 10.10.10.0.3. Okay, so that is for that network. Subnet mask automatically it will be set, and then let's set the clock rate to 64,000. And then the router 1 to router 2, it's now going to use the 11.11.0.2. For simplicity, we're going to follow the same form. Okay, so now router 2 is now configured. Now, let's now configure router 3. So, fast Ethernet is going to be 192.168.2.1. And then serial 2, if, okay, as we have seen earlier, serial 2, okay, let's check it out once again. So, okay, so 3 to 3 is, okay, so now we're going to set the IP address for serial 2, 0.11.11.0.3. Let's turn it on, and then for serial 3, so it's going to be 12, 12 point, okay, 0 and 3. And then turn that on. And now we're going to close. Okay, let's let's now try to check whether our connections are okay. So from PC1 to router 2, successful. PC1 to router 1, it's failed. Obviously because it would really fail because we have not yet configured the network with OSPF protocol. So in this particular tutorial, we're going to set up the OSPF. So we now go to router 0 command line interface. Now we're going to write the commands in configuring the OSPF. Before that, we need to go to config mode. So exit from this and then router OSPF 1. So what it does is that it gets into, so it's like one being the process ID. The process ID is one. Okay. So let's go ahead and let's add the network. So for router 0, the network is 192.168.1.0. And we also have to use the wildcard. So what does wildcard mean in packet tracer? We are now, it's like masking. Okay, it's like masking. Anyway, we're going to it's just this is just a demonstrating how to use OSPF, but later on we're going to discuss why we're going to use the mask. Okay, so OSP, what we're doing here is we're trying to complement the subnet mask. Okay, so instead of the 255, we're going to replace it with 0. So subnet mask is 0.0.0.255. Okay, so we need to also indicate the area. So that is going to be area 0. So the next network is we're going to configure is the 10.0.0. Okay, that is the network for router 0 to router 1. So the complement now is going to be 0.255.255.255 and area 0. And now, so another network is, the other network is 12.0.0.0. Okay, these are the connections to the router 0. Okay, so we're done with the configuring OSPF for router 0. So we now exit and then config settings, and then we need to save the NVRAM. Okay, so for router 1 and router 2, okay, same thing. What we're doing is configuring all the networks connected to that particular router. So router OSPF 1, okay, add the networks, network 10.0.0.0. So the mask is 0.255.255.255 area 0. And then the next network that is connected to it is the 11 network. Okay, so same process. So okay, okay, so we're now connected to networks. So done with the configuration, and then exit, and then config settings, and then don't forget to save. Okay, so now for the router 2, go to CLI, exit, and then router OSPF 1. The same process, network 192.168.2.0. These are the networks that is connected to. So 0.0.0.255, area 0. Okay. Next is the other network that's connected to it. So we're just connected to the 11.0.0.0. And then lastly is the 12.0.0 network. Okay, exit, config, and then save. Okay, we have figured it. Hopefully it's okay. So let's now check. So from P0 to router 0 successful, 0 to router 1 successful, yes. And then 0 to 2 successful again, 0 to 1. We did it correctly. The OSPF is okay. So now we're going to visualize it more with auto capture. As you notice, we send the message from 0 to PC0 to PC1, and then as you can see, it sent the packet to router 1 and router 2. It's updating the router table. It took the shortest path because through router 2 and then PC1. Let's try to do it again using the removing the other protocols. Let's do this again, and then auto capture, and then okay, there. As you can see, it's doing the handshake, and then sending from router to router is going to send and request signals, updating the routing table. Okay, now it identifies which has the shortest path. That's it. It's now sending back the acknowledgement through the same path. It shows that we configured it successfully, the OSPF. Hopefully you understood it. This is just a demonstration of how OSPF works. Okay, so that's it guys for this tutorial. Thanks for listening. Have a nice day. Bye.